Welcome to this explainer. Today, we're looking at something that honestly feels like pure science fiction, but it's rapidly becoming a highly structured engineering reality. We're breaking down a really fascinating presentation from Professor Hatem Eladi, all about future trends and grand challenges. Specifically, we're navigating the autonomous and regenerative urban frontier of 2050. We're going to take a journey into the astonishing, technologically converged city of tomorrow. So get comfortable and let's dive right in.
So, what does a city actually feel like when it can think for itself? Take a second to just ponder that. We usually view cities as these totally inert structures, right? Just concrete, steel, glass, and asphalt. But what happens when emerging technologies converge to make a city, for all practical purposes, alive? Throughout this explainer, we're going to use a biological metaphor to kind of map this all out. We're going to look at the city as a living organism to truly understand the tech convergence that's required to make this happen.
Part 1. The Blueprint, the Tech Convergence.
Part 2. The Brain and Reflexes, AIoT.
If you've ever accidentally touched a hot stove, your hand pulled away before your brain even consciously registered the pain. That's a reflex. Well, our 2050 cities need those exact same instant reflexes. And this is where edge intelligence comes in. It basically moves computation away from massive, centralized server farms and pushes it directly out to the urban edge, the streetlights, the traffic intersections, the waste management systems, and this leads to autonomous feedback, meaning these sensors don't just passively report data back to headquarters anymore, they act. Embedded machine learning allows them to dynamically adapt their operational parameters based on their environment in real time. They make instant decisions without the latency bottlenecks of waiting for some distant cloud server to reply. They literally become the city's automatic reflexes. But there's a major hardware problem we have to solve first.
Traditional computers run on what's called von Neumann architecture, which is just incredibly energy expensive when it comes to artificial intelligence. If millions of city sensors ran on traditional chips, we'd drain the entire city's power grid just trying to compute the data. The solution here is biologically inspired neuromorphic efficiency. These chips actually mimic the natural neural spikes found in the human brain.
And here is the staggering breakthrough. Neuromorphic chips offer a 100 times efficiency gain over traditional architecture. 100 times! This is an absolutely crucial leap forward for battery-powered urban sensors. It enables a persistent, always-on perception for autonomous systems throughout the city without constantly draining the municipal power grid.
To ground this brain metaphor and physical reality, we're talking about actual neuromorphic hardware, literal brains on a chip. It relies on microscopic superconducting circuits and Josephson junctions. This is the physical hardware that makes these intelligent, hyper-efficient, battery-powered sensors possible. This hardware is the physical gray matter of our 2050 city. But, as we know, a brain is completely useless without a nervous system to transmit its signals.
Part 3. The nervous system. 6G. The leap from 5G to 6G is absolutely mind-blowing. We are talking about a communication network that covers air, space, land, and sea, connecting everything for seamless urban logistics. I mean, we're jumping from peak data rates of 20 gigabits per second in 5G up to massive 1 terabit per second speeds in 6G. That enables instant large-scale data synchronization. And the latency? It drops from 1 millisecond down to sub-millisecond levels, practically zero. Why does that actually matter? Because sub-millisecond latency is strictly critical if you want to safely operate level 5 autonomous drone and vehicle fleets zipping around a dense city. Oh, and positioning accuracy jumps from meter level all the way down to centimeter level precision. But 6G isn't just about faster download speeds. It provides full domain coverage, meaning 6G actually acts as an integrated radar network. It senses the environment without the need for any extra hardware. The radio waves themselves map the environment, meaning the network is the sensor. It literally feels its surroundings exactly like a biological nervous system. And this nervous system enables what the source material calls a killer experience, holographic communication. We're talking about transitioning away from flat 2D video screens to volumetric 3D telepresence. This means remote conferences and teaching that truly feel physically present. It completely reshapes remote work, meaning the dreaded morning commute might finally become a thing of the past, which in turn will fundamentally alter how we lay out and design our city centers entirely.
Part 4. The Deep Senses, Quantum Sensing.
15 centimeters. That is the positional accuracy achieved by quantum sensing. It unlocks atomic precision by utilizing the weird, amazing properties of quantum physics, specifically entanglement and superposition. It allows the city to see into depths where standard signals just completely fail.
So, why does atomic precision matter to a city? It's all about navigation in what are called GNSS-denied areas. Think about deep tunnels, dense underground hubs, or massive urban canyons created by skyscrapers where standard satellite GPS signals just completely drop out. Well, quantum sensors achieve 70% better accuracy than GPS, allowing autonomous systems to perfectly navigate these dead zones. They also offer an 82% drift reduction over existing LiDAR systems, meaning robots stay on course reliably over the long term. And perhaps most incredibly, it allows for non-invasive underground mapping using something called gravity gradiometry. The city can detect hidden pipe leaks, sinkholes, or density shifts through solid ground without ever lifting a single shovel.
Part 5. The immune system. Grand challenges ahead. So the city is intelligent, it's lightning fast, and it sees everything. But a complex organism is incredibly fragile, meaning it needs an immune system. Our source material outlines 3 primary grand challenges to keeping this ecosystem secure. Step 1 is hypersecurity. When literally every lamppost, trash can, and traffic light becomes a computing node on the network, the attack surface for bad actors expands exponentially. Securing these billion-node networks is the absolute #1 hurdle. Step 2 is heterogeneity, and Step 3 is privacy. Let's look at that second hurdle. There is a massive interoperability gap. You've got totally diverse hardware, microcontrollers, FPGAs, nano-electromechanical systems, all trying to speak the exact same language so they can operate under a single unified urban OS. It's an immense engineering puzzle, and alongside that puzzle is the challenge of privacy by design. Processing data locally at the edge absolutely helps protect individual identities, but we can't ignore the inherent risk of aggregate surveillance when a city has eyes and ears literally everywhere. Which leaves us with a deeply provocative question. As we build the ultimate urban convenience, a regenerative, autonomous city with zero traffic, zero waste, and perfect efficiency, how do we ethically oversee an aggregate surveillance network? It's the ultimate balancing act. We're engineering a hyper-connected, brilliant organism, but we must consciously preserve the fundamental necessity of individual privacy within its walls. It's a massive challenge for sure, but as we've seen today, the blueprint for 2050 is already being drawn. Thank you so much for joining me for this explainer. I really hope this structured journey helped you grasp the incredible convergence of technology right on our horizon. Keep learning, and I'll catch you next time.